Hello, everybody, and Happy New Year. So today I will talk about P versus NP problem in this video. I actually learned this concept quite recently when I was doing the read code, and I did some investigation, so I will summarize what I learned in this video. So the content will not so be deep. It will be quite basic and overviews, but I will try to make it easy to understand as much as possible. So that being said, let me get started. Okay, so now I start with the word definitions. So P and NP. So what are these? So P is polynomial and NP is non-polynomial. I will show it to you. Obviously, and probably you should know, but P is polynomial, so it looks something like this: 2n, 2n plus 2, n log n plus n squared. These are all polynomial. And non-polynomial, this is something like this: 2 to the n, 3 to the n, or maybe 2 to the n plus n log n. So something to n. Roughly saying, this is a non-polynomial. Yeah. So yeah, obviously non-polynomial time complexity. If it is the time complexity, it grows quite rapidly. So we'd like to solve algorithm questions in polynomial time complexity. So please keep this in your mind first. And that being said, if we can say every problem can be solved in polynomial time complexity, it is great. But actually, there are many questions which whose polynomial solutions hasn't been found. So for those questions, we'd like to find polynomial solution, or at least we'd like to say if polynomial time complexity solution exists or not. And in this video, I should say, in P versus NP problem, the main focus is whether polynomial solution exists or not. So this is something I'd like to know. We'd like to know in this P versus NP problem concept. Okay, so please keep this in your mind first. Okay, so I come back to this chart, but please keep in mind this NP means something a bit different. I will talk about it from now. So P problem is a problem that can be solved and verified in polynomial time. So here there is a new concept: solve and verify. So let me talk about this. So what is solve and verify? So obviously, as you know, solving the question is to find the answer, and verifying the question, or I should say verify the solution, is confirm that the answer you found is correct or not. So I think most intuitive example is Sudoku. So you'd like to fill in 1 to 9 numbers, yeah, in each cell, and you'd like to make sure that the same, duplicate number doesn't appear in the same row or in column. And also there is a kind of submatrix like 3 by 3, and you'd like to make sure that there's no duplicate in this submatrix 3 by 3, and you'd like to fill 9 by 9 matrix cells. And when you try to solve this question, it basically takes 9 to 81 time. And when you think of the generalized version like this, it takes n squared times, I mean, to the n squared. So this is obviously NP problem. So solving, you know, pseudo question takes NP time. However, verifying doesn't take this much because you directly linear scan the row, each row, and confirm, no duplicate, and also do it for the, each column, and do the same for each matrix. So basically, it takes, how much time is it? So n squared, n squared, n squared. So all of n squared time complexity only. So verifying pseudo answer takes only the polynomial time. I think you can understand it intuitively. Because when you have the completed pseudo cells, you can easily confirm the answer is correct or not. So pseudo is a very good example to understand what is solving and verifying. Okay, so I come back to this chart and I will talk about the definition here with the explanation I gave you. So P problems is the problems defined, um, I mean, which can be both solved and verified in polynomial time. And NP problem here is defined as the problems where a given solution can be verified in polynomial time. So just keep in your mind that there is a question which cannot be solved in P problems. Not all of them are NP problem. So NP problem here is has to be at least verified in polynomial time. Okay, and because of this definition, I can say P here belongs to NP because obviously P problems can be verified in polynomial time by the definition. Okay, so this is NP problem. Okay, so from here, I will talk about NP hard. So NP hard is, as you can see here, defines as the problems to which any NP problem can be reduced in polynomial time. So it sounds a bit confusing, so I will explain what I mean by this. So I don't give you the, strict definition here. Just I will give you a feeling of what it means. So let's say there is a problem, and this is NP problem. So NP problem means that it can be at least verified in NP time complexity. And there is another problem. And here, let's say this problem A can be kind of converted into problem B in NP time, no, polynomial time complexity. This is just an example, but let's say you were given the kind of binary search question, and maybe you can convert that question into the similar or maybe completely different question in P time. In that case, what I can say is if you can solve this question in P time, polynomial time, that means that you can also solve this question in P time. Because converting takes P time, solving converted question takes P time too. So in total, it takes only p time, polynomial time. And this NP hard, actually NP hard is number 3 and 4. So this circle is a question that any NP problem can be converted into in polynomial time. So in mathematics, we should use the term reduce. So let's say reduced. So obviously, there's so many NP problem C, problem D, blah, blah, blah. All of them are NP problems. Any problem can be reduced into this question in P time. Then I can say this question is NP hard. Okay. So I hope you understand what I mean. So I will continue. Consequently, if any NP problem could be solved in polynomial time, then all NP problems could also be solved in polynomial time. So NP hard problem, there are some NP hard problems, obviously. And for each, by definition, NP problems can be reduced. So these are NP hard questions. Yeah. NP hard. Problem maybe E or F. So if any of these NP hard question can be solved in polynomial time complexity, then I can say any NP problem can be solved in polynomial time complexity. So let's go back to the word definition. So NP problem is a question which can be verified in polynomial time complexity. So which means that if you can find the solution for any of these NP hard question, then you can say NP problem can be solved in polynomial time complexity, which means that the question which can be verified in polynomial time complexity can be solved in polynomial time complexity. Yeah, because as I said, once you, let's say, you could solve this question. Good. Which means that NP problem, which is solve verify polynomial. So those questions can be solved in now P polynomial time complexity. So by word definition, this NP problem is exactly P, problem. So this is maybe you've heard of it, but you can say P is equal to NP, and you can say if once you confirm that you can verify the solution in polynomial time complexity, then that question can be solved in polynomial time complexity too. Okay, so this is what I mean to say here. So I hope you understand how interesting this is, because once you find the solution of any NP hard question, then you can say if the question can be verified, sorry, if the solution of the question can be verified in polynomial time complexity, then you can say solve that question with polynomial time complexity. The good example is Sudoku. Okay, so this is about NP hard questions. Okay, so this is the kind of main content of this video, but I will add some minor details here. So maybe you've heard of the word NP complete. So what is it? The NP complete is an intersection of NP hard and NP. So I can say if the question can be verified in polynomial time complexity, it is NP. And also NP hard, which means that any NP problem can be, reduced in polynomial time complexity. Then you can say the question is NP hard. So NP complete meets both of them. Yeah. And I just added this word here, NP complete, because this is probably the quite famous term and you've heard of it. I just wanted to clarify what it is. So, and these are strictly decision problems. So, like yes, no answer is asked in those questions. So, NP complete, any NP complete question is decision problem, but it doesn't apply to, here NP hard, but not NP complete. So this, area number 4 has both decision problems and other kind of problems. Okay, so I will give another minor detail. So here, just to be clear, I've just updated this sentence. Okay, so non-complete NP hard problems, number 4, this area. Some of these questions are already proven to be unsolvable in polynomial time complexity. So I told you that if you can solve these questions, any of these questions in polynomial time complexity, you can prove P is equal to NP. But also I can say some problems are already proven that you cannot solve it in polynomial time complexity. So yeah, if you'd like to try, you have to, try questions aside from those. Okay. Okay, finally, I will give you some examples of P questions and NP questions, NP complete, non-complete, NP hard questions. Yeah, obviously you can know these questions by asking ChatGPT or Gemini, so I don't go deeper into this. But yeah, there are so many questions which are clarified to each of them. Okay, that being said, I'll finish my today's video, P versus NP problem. So if there is a mistake, please write it in the comment section. And if you have some opinion or, feeling like this was interesting or maybe boring, also please write it in the comment section. And also you can request me any content and I will try to create the videos. Okay, that being said, I finished my today's video. Thank you for watching. Bye bye.